In this chapter, we're going to explore one of the really fundamental challenges in modern software development. As a development team gets bigger, trying to get everyone to work together, well, it gets messy and fast. It's so easy for developers to accidentally overwrite each other's work, introduce new bugs, and just generally create what feels like, organized chaos. The tool that's designed to bring some order to all of this is called a version control system. But just using one isn't enough. Using it effectively, especially with a big team, is both an art and a science. So let's dive into how we can really master it.
I mean, really, this is the big question, isn't it? Just stop and think about a huge project for a second, like an operating system or a major website. You can have hundreds, sometimes even thousands of engineers all contributing to the very same codebase, all at the same time. So how on earth do you manage that kind of workflow? How do you keep things moving forward efficiently while making sure the final product is actually stable? How do you stop the whole thing from collapsing into a tangled mess of conflicting code? This is the core problem that advanced version control strategies are built to solve.
Okay, so here's our game plan for this discussion. We're going to start by digging into that collaboration challenge a little deeper. Then we'll take a quick trip back in time to see how our version control tools have evolved. After that, we're going to tackle the big one, branching. It's a super important and often pretty debated topic. From there, we'll look at some concrete strategies to keep your workflow sane and manageable. And finally, we'll wrap it all up with the one core principle that really ties everything together, the idea of integrating, not isolating your work.
Right. Let's start by looking at the challenge itself. So, how do we solve this problem of many hands in one codebase? Well, that's exactly what version control systems are for. At their heart, they keep a perfect, detailed history of every single change ever made to an application. Who made the change, when they made it, and exactly what that change was. And that historical record, it's absolutely invaluable. Plus, these systems provide the whole framework that lets multiple developers work in parallel on different features or bug fixes, all within the same project.
So this is the fundamental balancing act of version control. On one hand, the system has to allow for separation, letting developers work on their own pieces of the puzzle without stepping on each other's toes. But at the same time, it has to maintain unity. It has to guarantee that there is always a single, authoritative source of truth, what we often call the main line or the trink, that represents the true, stable state of the application. The real trick of any version control strategy is figuring out how to balance these two competing needs. Now, the sophisticated tools we have today didn't just appear out of nowhere. They're actually the result of a long, long process of evolution. And their history is really a story of engineers constantly trying to find better and better ways to solve these collaboration problems. Each new generation of version control was basically built to fix the headaches and limitations of the one that came before it. And this timeline shows the evolution perfectly. It all started with really early systems like SCS way back in the 70s, the granddaddy of them all. Then came CVS, which was a huge step up because it made the idea of concurrent work popular, letting multiple developers edit the same files at once. Then in 2000, we got Subversion, which set out to fix some of the big flaws in CVS, especially by introducing something called atomic commits. But then, around 2005, everything changed. A massive paradigm shift happened with the arrival of distributed version control systems, or DVCS, with Git leading the charge. This new model completely redefined how developers work together. Let's look a little closer at that jump from CVS to Subversion, because it was a big deal. The key difference is all about how each system thinks about changes. In CVS, changes are tracked file by file. So if you change 10 files, the system would log 10 separate little history updates. Subversion, on the other hand, introduced the idea of an atomic revision or change set. What this means is that all 10 of your file changes get bundled together into a single all-or-nothing transaction. If that transaction fails for any reason, the whole set of changes is rolled back. This was a massive improvement for reliability because it meant the repository could never be left in a broken, half-updated state.
Another huge philosophical shift was in how these systems handle potential conflicts when people are editing at the same time. Older systems used a strategy called pessimistic locking. You can think of this like a physical key to a file cabinet. To edit a file, you have to check it out, which basically locks the drawer so no one else can touch it. As you can imagine, this can really slow a team down. Modern systems, thankfully, use optimistic locking. In this world, everybody works on their own local copy of the files. Everyone can make changes at the same time, and the system is smart enough to help you merge those changes together later. It's built on the optimistic assumption that direct conflicts are pretty rare, and it's a much, much more flexible way for teams to work.
And this brings us to the biggest evolution of all, that move from centralized to distributed models. In a centralized system like Subversion, you have one single central server that holds the master copy. Developers check out code from that server to work on it and then check in their changes. But in a distributed model like Git, every single developer has a full copy of the entire repository, the whole history and everything, right on their local machine. Committing your changes is a totally local thing, which makes it super fast. You're not dependent on a network connection. This distributed nature is what makes incredibly powerful workflows possible, like working completely offline or experimenting with big changes in private. It's really the key reason Git has become so popular today.
Okay, now let's get to the heart of the matter, branching. Branching is, without a doubt, the most powerful and flexible feature in any modern version control system. It's what allows for parallel development, it makes it safe to experiment, and it's essential for managing software releases. But it's a double-edged sword, and if you use it without a clear, disciplined strategy, branching can lead to some serious complexity and chaos.
So what is a branch, really? Well, at its core, you can just think of a branch as creating a separate timeline for your code. When you create a new branch, you're essentially saying, I want to create a new line of development that starts from this point. It gives a developer, or a whole team, a safe, isolated sandbox to work on a new feature or fix a bug, all without affecting the stability of the main version of the code.
And this picture, this right here, is a powerful visualization of what happens when branching goes wrong. This situation has a name, and it's called merge hell. It's what happens when you have lots of different branches that live for a long time. One for this feature, another for that bug fix, a third for some performance tweak. Over time, all these separate timelines drift further and further apart. And when it's finally time to bring them all back together for a release, well, the process of merging them can become an absolute nightmare of tangled code, complex conflicts, and just pain.
And here's the most important takeaway from all of that. The difficulty of a merge comes down to two things: how much time has passed since the branches split, and how different they've become. A codebase is a living, breathing thing. It's always changing. So the more changes pile up on two separate branches, the harder it's going to be to weave them back into a single coherent whole. In this world, time is your biggest enemy. The longer you wait, the worse it gets. It's as simple as that.
So now that we've seen the problem, we've seen the monster, let's talk about the solutions. If merge hell is the dragon we need to slay, then the branching strategies we're about to cover are the weapons we can use to fight it. The goal isn't to stop branching altogether. It's about learning to use it in a smart, disciplined, and strategic way.
The first strategy, and honestly the one that's most often recommended, is also the simplest. Just don't use long-lived feature branches. Instead, the entire team commits their changes, small, incremental changes, directly to the main trunk, or the main line, all the time. Ideally, at least once a day. This practice is called continuous integration, and it forces everyone's work to be integrated constantly. It basically ensures the codebase never drifts apart into conflicting states, because any integration problems are found and fixed immediately, while they're still small and easy to manage.
Now, here's a sane and really effective way to use branches, the branch for release strategy. In this model, all the new development, all the new features, they still happen right on the main line. But when you're getting ready to cut a new release, you create a branch from the current state of that main line. This new release branch is now a stable, isolated environment. You use it only for final testing, quality assurance, and fixing any last-minute critical bugs. And the best part? The main development team can immediately start working on features for the next release right on the main line without ever having to stop.
This slide just shows the difference so clearly. On the left, you've got that chaotic, tangled spaghetti that represents merge hell. And on the right, you see the clean, straight, predictable flow of a disciplined branch for release strategy. It's the visual difference between a reactive, painful integration process and a proactive, controlled release cycle. The goal is always to keep a single, continuously integrated main line that's always moving forward. Okay, we have to talk about a very common, but also very dangerous pattern, branch by feature. Now, the idea of creating a separate branch for every single new feature, it sounds so organized and appealing at first, right? But in practice, this approach is the exact opposite of continuous integration. It encourages developers to work alone, in their own little bubble for days or even weeks. And you're not getting rid of merge conflicts this way, you're just delaying them. You're kicking the can down the road, and that can is getting bigger and more complex every single day, until it finally explodes right when you can least afford it, just before your big release.
So as we start to wrap this up, what's the one big idea you should take away from all of this? Well, it can really be summarized in one simple philosophy, a mantra that should guide all of your version control decisions. Integrate, don't isolate. This quote from our source material just says it all perfectly. Using long-lived branches that are rarely merged is a trap. It might feel like you're neatly organizing the work, but what you're actually doing is building up a huge amount of risk and technical debt that will eventually come back to bite you as merge hell. It's a path that almost always leads to a stressful, unpredictable, high-risk integration phase that's going to cost your team a ton of time and money. The antidote to this problem, the ultimate weapon against merge hell, is a practice called continuous integration, or CI. So what is it? It's the simple but incredibly powerful practice of having every single person on the team merge their work into the shared mainline frequently. And I don't mean once a week, I mean multiple times a day. By integrating constantly and in tiny, manageable pieces, you get instant feedback on the health of the codebase. It keeps the code from ever drifting too far apart and ensures that any integration issues are found and fixed the moment they happen.
So to sum it all up, here are the key habits that will lead you to a sane and effective way of working together. 1. Commit your work to the main line at least once a day. 2. Break your work down into small, incremental changes. 3. Whenever possible, do your new development work directly on the main line. 4. If you absolutely have to use a branch for a release or maybe a tiny, short-lived task, make sure it gets merged back in or deleted as fast as possible. And 5, the big one, integrate constantly. It's all about getting that fast feedback to maintain a healthy codebase.
And that brings us to our final question, one for you to think about. I want you to take a hard look at your own team's version control practices. Is your current strategy actually helping you collaborate and deliver value smoothly? Or is it just maybe, creating a bunch of isolated silos and just kicking a massive integration problem further down the road? The answer to that question will tell you a whole lot about the health of your development process.